Study about derivations. We are going to learn how to derive the equation of motion that we did in the previous video. Okay, first of all, the derivation is going to start from the definition of acceleration. Acceleration by definition is the change in velocity with respect to time. Change in velocity can be also be written as v minus u upon t. Okay, now let me make it clear that throughout the discussion v will mean the final velocity, u will mean the initial velocity, s will mean the displacement or the distance, and a will mean the acceleration, t will mean the time. This is the key. Okay, from the definition of acceleration, acceleration equals the rate of change of velocity, which is the change in velocity with respect to time. So final velocity minus initial velocity upon time. If we rearrange this equation, it becomes v is equal to u plus at. This is our first equation of motion. Now, this is how we derive it. And the second equation of motion is also very simple and is going to be derived from using the first equation. We know that average velocity, actually the total displacement, is equal to average velocity multiplied by time. Okay, average velocity multiplied by time. This is basically that speed equals distance upon time formula. So average speed, average velocity formula, displacement multi equals average velocity multiplied by time. Okay, excuse me. Average velocity can also be written as v plus u upon 2, final velocity plus initial velocity upon 2. This is the average velocity. If we substitute the average velocity over here by v plus u upon 2, we'll get u plus v upon 2, the whole thing multiplied by time, equals displacement. This is our second equation of motion. In this case, we have the initial velocity, we have the final velocity, we have the time, we have the displacement, but only acceleration is not here in this equation. So acceleration cannot be calculated using this equation, whereas all the other variables can be calculated. Now, these two equations of motions can be used to derive the rest of the equations of motions. V equals to u plus at and s equals u plus v upon 2 times t. Over here, this v can substitute the v in this equation. So the v in the first equation, let's plug it into the v of the second equation. So it becomes s is equal to u plus at, the whole thing divided by 2 multiplied by t. Okay, so if we open it up, it becomes 2u plus at upon 2 multiplied by t, and on further simplification it becomes s is equal to ut plus half at squared. This is our third equation of motion. Now let's calculate the fourth equation of motion. Let's derive the fourth equation of motion. Okay, in this fourth equation of motion, at first what we did was we plugged in the v in the second equation. Now let's make u the subject. Making u the subject, it becomes v minus 80. Plug in v minus 80 in place of u in the second equation. So it becomes s is equal to v minus 80 plus v on to whole thing multiplied by t. On simplification, v plus v becomes 2v minus 80, the whole thing divided by 2 multiplied by t equals s. Let's simplify it further. So it becomes s is equal to vt minus half 80 squared. This is our fourth equation that we've derived. Okay, now let's go to the last equation. As I told you guys earlier, v is equal to u plus 80 and s is equal to u plus v upon 2 times t, 2 times the whole thing multiplied by t, can be used to derive the rest of the equations of motions. So let's do that again. This time make t the subject in the first equation. So when we make t the subject, it becomes t is equal to v minus u upon a. V minus u upon a, when plugged in place of t, it becomes s is equal to v plus u upon 2 multiplied by v minus u upon a. Now v plus a when multiplied by v minus a, so according to the identity of mathematics, a squared minus b squared equals a minus b multiplied by a plus b. This becomes v squared minus u squared upon 2a being equal to s. Now just rearrange it. It becomes v squared equals u squared plus 2as. This is our last equation of motion derived. Okay guys, thank you so much.